Hello, everyone, and welcome to Parity and Friends. I'm Caroline, and I am your host today. Before we get started, I want to quickly talk about Polkadot Decoded, which is our conference happening on May 20th. At the moment, we have an open call for participation, which closes this Sunday at 10 p.m. So we're definitely encouraging you to submit your talks and ideas. We have 6 different formats that you can submit a talk through. These are from Polkadot Vision, Polkadot in Action, Lightning Talks, Tech Talks, and workshops. So we're really getting a broad spectrum of like non-technical talks and technical talks. So it should be a pretty exciting event. And not only that, with the submissions that we have coming in, these will also be placed to an open vote. So this is a truly decentralized program we're making. We really want it to be community curated. And so we're excited to see how this formulates from what you guys want to hear about. So definitely participate. I've just added the link there in the chat and hope to see your submissions come in. So now on to today's event. We have 2 great talks lined up for you. First off, we have Silva, one of our core developers at Parity Technologies. He's going to be talking about the journey developing the finality gadget Grandpa and the blockchain production mechanism Babe and their related subsystems. And then following that, we have co-founder and CTO of Bit.Country, Shannon Christie, talking about the vision of their decentralized virtual world, their goals and challenges, and the Bit.Country project, and how and why they decided to use Substrate. So super cool. For the event, at the end of each talk, we do have time for Q&A. So if you have any questions you would like to ask, please submit them in the Ask a Question function just down the bottom to the left of the chat box. And then we also have a few polls. So if you could take a moment to fill out the polls, it's 3 short questions. We'd really love to hear your feedback on if you've been to our event before, what's your experience with Substrate and Polkadot. This just helps us curate our events in the future, just knowing our audience and what kind of experience you have and who are we talking to. So without further ado, I'm going to hand it over to Andre to talk about the breakthroughs and challenges of Polkadot Consensus. Take it away.
Yay. Okay. So I think everyone should be able to see my screen now. Okay, so yeah, in this talk, we're going to be talking about the consensus of Polkadot and, not going into the details of how it works. There's already a lot of content on that, but actually about what broke while implementing this stuff, what challenges we faced, and most importantly, how we overcame them. I'll only be talking about the relay chain consensus, so only how we make new blocks, how we finalize them, and not so much about parachains or cross-chain message passing, which also fall under the umbrella of consensus. So I will not be talking about how these actual protocols work in detail. Just in 5 slides, I'll give you the bare minimum to make this talk useful if you don't know anything about it. So in Polkadot, we have this hybrid consensus, which means that we have different protocols, one for creating the new blocks, and then another different protocol for finalizing those blocks. So the protocol to create new blocks is Babe, which stands for Blind Assignment for Blockchain Extension. And the idea is that we split time into slots. In Polkadot, these slots are like 6 seconds apart. And for each slot, we basically assign some validator that is the owner of this slot. And you, as a validator, if you own a certain slot, then you get to author a block on that slot. The important thing here is that the assignment is done randomly, and no one knows who is assigned to what. This is done using the VRF, which stands for Verifiable Randomness Function. You can think about it as just a random number generator that gives you cryptographic proofs of actually generating some random number. So in practice, in very, very simple terms, the way that this works is that at every slot, you, as a validator, try and generate a random number using your private key as input. And there's some threshold. And if the number that comes out is lower than this threshold, then the slot is yours, and you can author a block. the important thing here is that it's not a normal random number generator because you actually get a cryptographic proof as output of you executing this function. So everyone else can verify that yes, indeed you got 14 and you're not lying. So this is very similar to how proof of work works, right? In proof of work, you also have this stochastic process. You're basically trying to find some nonce. For example, in Bitcoin, you're trying to find some number which, when hashed, will give you an hash which has a leading number of zeros. This is like the threshold there. So the idea here is that we want to get the same properties. We want this to be random. We want this to be blind. But we don't want to waste all of that, do the actual work, the useless work of proof of work. So here we just run this function. There's no hard computation associated with it. Yeah, and this is Babe. It's all you need to know for now. On top of this, we have Grandpa. Grandpa is basically, once we have these blocks that are generated by Babe, we run this protocol which goes in rounds, and it does basically this two-phase commit, where everyone might be seeing different chains, and they will vote on what they believe is the best chain. And using these votes, the protocol will find some common ancestor in the chain where more than 2/3 of the validators agree on it. This is the BFT part, right? This only breaks if more than 1/3 of the validators are dishonest. Otherwise, it's always consistent. What gets finalized never gets reverted. So visually, this is how it works. Like, we have our blockchain here, and we can see that we have like these 3 open forks, right? And here on the right-hand side, we see the validators, and each of them is voting like potentially for different blocks, right? And the protocol, the way that it works is like it assumes that if you voted for this block, implicitly you also agree that this block is fine, right? Because otherwise this block wouldn't be fine. You're building on top of it. So the protocol looks at all of the votes, and they should flow up this tree, and there should be some common ancestor where more than 2/3 agree on it, which is this one here, right? Because we have 7 validators, six of them are voting for this subchain. So this one for sure, everyone agrees on, and it gets finalized. And in very simple terms, this is Grandpa. The important takeaways here when we compare Babe to Grandpa is that Babe will favor availability, because it doesn't need these 2/3 of validators to come to consensus at every round. But it's eventually consistent. Just like proof of work, you might have temporary forks, and they will resolve with time. Whereas in Grandpa, we are favoring consistency. Like, we will never finalize 2 different conflicting forks. But if people go offline, then we don't make any progress. So this is the minimum introduction necessary. Now let's look at what broke while implementing this. So the first thing with Babe, it was just a matter of like bad user experience. So before Babe, we were using Aura, where the slots, we also used slots, but the slots were assigned deterministically. So it was guaranteed that the block would come out every 6 seconds. Whereas in Babe, just like in proof of work, slots are assigned randomly. They might be assigned to 1 validator, multiple validators, or even no validator at all. And there's also this parameter C of the protocol that defines how many slots are filled. So for example, if we have this C set at 1/4, it means that in every 4 slots, only 1 of them will be populated. So if we have a slot duration of 1 second, it means that the block time should average out to 4 seconds, but there will be a lot of variability, just like in proof of work. In Bitcoin, the block times should be around 10 minutes, but sometimes it's 2 minutes between blocks, sometimes it's 20. And this just felt like a downgrade from what we were already used. We really wanted to get like this deterministic block time. So we introduced this notion of the secondary slots, which are assigned deterministically. and we make sure that they are always assigned to someone. So we can just ignore this function here. We can just assume that, for example, we will go in round robin over the validators. The point is, if there's no primary, someone else will be assigned to a secondary slot. So for sure, someone else will author a block. And what we had to do was just make sure that the fork choice rule was to always follow the chain with the most primary slots. And yeah, basically after this, we went back to having a block every 6 seconds deterministically. The next thing was, forks. As Babe, as I said, like it might be the case that multiple validators get a slot. So this means that we will have a temporary fork that will be resolved, rather soon, but it will still happen. And then, since we added the secondary slots, this also introduces the possibility of more forks, because whenever someone gets assigned a primary, someone else will be producing a secondary block, which will eventually be ignored. The important part here is that before, we were not having forks, and even though our code base was already prepared to deal with forks, this started exercising different parts of our code, so we started seeing different bugs in practice. The first bug that we saw was related to the state cache. So whenever we would reorg from fork A to fork B, because grandpa finalized fork B, the client would not update the state cache. So the state would still have the values from the previous fork. When this happened, which was like 2019 or something, this was just on some very small test nets. There was not a lot of happening there, not a lot of transactions. So it was very likely that if you had these two blocks, this fork that was just one block long, it was very likely that the state would be the same across forks. So this bug wouldn't even show up, even though it was there. But with Babe, like since we started tracking like randomness on chain, and random values are random, we immediately started seeing this bug, and it was just a simple thing, but it was just a matter of it surfacing. The next set of bugs was related to making sure that the client would sync all of these forks. Sometimes the client would get stuck and would stop syncing the longest chain, would get stuck on this minimal fork. It was just edge cases in the sync logic, like small things that aren't even worth mentioning. The important part is like how I solved these issues, which was I gather logs of the failures. I would write a small description of what happened. I would send both these things to Arcady, and then I would wait, and I would approve the pull request. Like this method never failed for me. It fixed all of the bugs in the sync logic. But the important thing is, like, if these forks are short-lived, like, why do we even care? Like, if someone authored a secondary slot and it was overridden by a primary slot, the chain progressed. There's now a longer chain. Like, why do we even care about syncing these forks? And the answer is that even though the fork is short-lived, there's the possibility that some grandpa voter voted on this fork. And as we've seen earlier, in order to process the grandpa votes, you need to find out the ancestry of the vote, right? If someone voted for some block B, you need to know its parents and all of the ancestry so that you can calculate the common ancestor. So if you don't import the forks, you cannot process the votes, which eventually means that grandpa will stall and stop finalizing. And there were two main things that caused this to happen. First one was missing state. So the client does state pruning because this occupies a lot of space on disk. And so after some number of blocks, which by default is 256, we would basically prune the state. And if we don't have the state available, it means that we cannot import the blocks, right? In order to import block 10, as input to the state transition function, you need to have the state for block 9. So we basically put out the requirement that validators need to run archive nodes with node state pruning. This is still the case today because we are being conservative about this. But we also made sure that the syncing logic would fall back to syncing only the headers if the state is not available. So basically, it will just behave like a light client. For Grandpa, this works because we don't really care about executing the block. We just need to check the header ancestry. We just need to check the chain. So this solves the problem there. The other issue was, missing some block announcement. So the way that sync algorithm works to sync all the forks is that whenever you import a new block or you make a new block, you will send a small message to the peers that you're connected to saying, well, I just imported this block, here's the hash, and if the peer doesn't have this block, then he will then ask it from you. Which means that if we don't get this block announcement, then we won't sync the fork. And we might not get the block announcement because of some bug or networking issue or whatever. But the point is that we should be able to recover from this. So the solution here was that the sync module started exposing some API where the higher level layers could inform it to say, well, this block exists, so please figure out with the peers you're connected to who has it and try and sync it. And Grandpa started using this API and would basically request to sync the blocks that you would see on the votes. So if it saw a vote for a block B and it didn't have this block B, it will say to sync, well, this block B exists. Please ask your peers and try to sync it. So these two things alone, made it so that we no longer had any issues with like syncing the multiple forks. So next we go into the issues with communication in Grandpa. So as I said, like we are voting every round. The validators create these votes and they need to gossip it around. And this is the description. You don't need to read this. This is the description that exists on the Grandpa paper of the protocol. It basically says like when you are supposed to vote, what you are supposed to vote for, when, who should you send the message to, blah, blah, blah. But the important thing is that it just says that stuff like, and then you broadcast the vote. Like that's the extent of detail that we have. We are supposed to broadcast the vote somehow throughout the network. So we can just implement this gossip infrastructure relatively simply. We can have a function broadcast that gets a message as input, and you go through all of the peers that you're connected to, and you send them the message. And when you get some message from some peer, you broadcast it to all of your peers as well. And this simple implementation has some advantages. Like it's easy to understand. It's obviously correct, right? It's like this is like 8 lines of code, so it's for sure is correct. And it's low latency. And this is the end result. You would basically start maxing out your connection. This would be a great way to test your connection and to test your networking layer, and in the end, to basically self-inflict DDoS on your own testnet. I mean, this is what really happened. Obviously, we knew that this was not a scalable gossip protocol. I mean, even the first implementation wasn't as naive as that. I'm exaggerating. But at this point, I mean, this is like 2018, 2019. We didn't really care about the gossip yet. We were still trying to make sure that the Grandpa protocol was correctly implemented. So we were just delaying solving this problem. There were like lots of hacks, like you can see like these tiny tweaks to try and make it work without solving it properly. But at some point, we really needed to solve it and make it like DDoS-proof. And so we identified 2 distinct problems. The first one is to figure out which peers we should send data to. because yeah, we don't want to be sending like duplicate data and flooding everyone in the network. And as a result, there will come this network effect where if everyone is restricting the data that they send, we as a whole, as a network, we minimize the amount of duplicate data that we are receiving. And then the other thing is we also need to figure out which peers that we should stay connected to. Like, is the peer responsive? Is the peer following the protocol rules correctly? Is the peer sending us data that's useful? Yeah, so these are the two problems that we needed to tackle. The first one, we basically created this network protocol for Grandpa, which we called like the polite Grandpa. And the idea is that the peers will share like small messages with each other, basically relaying their local state with regards to Grandpa. So they can say to a peer, well, I am on round 10 of the set ID 1, and the highest block that I've seen finalized is block 10. And then using this small, sharing this local view with all of the peers, we can define some notion of impoliteness. For example, it's impolite to send the same message more than once. Like it's impolite to send messages for a round that we're not interested in. For example, if we say to a peer, I'm at round 10, like I don't care about the data for round 5. Like I'm already past that, so you shouldn't send it to me. And basically, all of these impolite interactions will incur some cost, which will eventually help us in deciding whether this peer is good or not. And this is the next step. So we created this peer set manager exactly to do this thing. It's the idea is to have just a central place in the code that manages all of the peer connections. There's a single component that's responsible for defining who we are connected to, if we should connect to some new peers, if we should drop some peers that we are connected to currently. And the idea is that we do this on, basically we track some notion of peer reputation. So every high level layer, for example, Grandpa, syncing, parachains, can report to the peer set manager every time it interacts with a peer. So for example, if I'm syncing and I ask for a peer, please give me block 10, and he comes back and gives me block 9, I mean, this is wrong, this as a cost, and we will report this to the peer set manager. If I ask for block 10 and I get block 10, this was a beneficial interaction for me, and I will report this to the peer set manager as well. The idea is that using this high level information, we can create this abstract notion of peer reputation, and then we just need to make sure we keep connecting to the peers that are most reputable. Okay, and this is the last thing that I'm going to mention here, which is related to how authority set changes actually work in Grandpa. So the authority set is not static, right? We have staking. Every era, we are running these elections. People are nominating validators, and based on this, we decide who the next validators will be. And this is done entirely in the runtime. So yeah, these elections, the result of the elections goes in the runtime. And so whenever a new era starts, this block will have some digest that says, the authorities have changed, and these are the new authorities. The important part here is that the Grandpa voters will not immediately do the authority set change. So what they'll do is they'll note this change. They'll be on the lookout for these digests whenever a block is imported, and they'll collect this change and put it into like a queue of pending changes. And they will only enact the change. They will only actually change the authority set once the block that signaled the change is finalized. And this is how we can do the handoff securely. Like you can imagine that, imagine that in Babe there was a fork right at the block where the elections happened. And in one fork, the authorities are B and C, and in another fork, the authorities are A and B. Like we cannot, we need to have a stable validator set for Grandpa to switch securely. So if we wait for finality, we know for sure that the validators for set 1, like more than 2/3 of them agreed that on who the next validators will be. Yeah, so this is why we wait for finality. But this also means that the actual active authorities in Babe and Grandpa might get out of sync if finality is lagging. So for example, imagine that on Polkadot, an era is 1 day long. Imagine that finality stops for like 2 days. It means that the Grandpa validator set will be the one from like 2 days ago. But this begs the question, like, what happens if more than 1/3 of validators go offline? Like, how do we recover from this? Because, they went offline, so we cannot skip to the new validator set because we need the previous one to finalize it, but they're offline. Like, we have this chicken and egg problem. And, in practice, and, this shouldn't happen, but on early test nets, this was bound to happen. The validators were not incentivized to be online. There was no token with value, and there were bugs, that would cause finality to stall, and which required you to update the client software. And it was bound to happen, and it did happen a bunch of times. We just had to manually engage with the community to solve these problems as they happened. But as I said, this shouldn't happen on a production network, but we still needed to have an answer for, if this catastrophic scenario really did happen. So we introduced this notion of forced authority set changes, which basically it's an authority set change that will be enacted immediately. Like the Grandpa voters won't wait to finalize this block. And obviously this breaks the security of Grandpa. And this is why this can only be triggered by root. So we have this call, this runtime called, the node stalled, and basically only root can call this, which means that in Polkadot, this is governance job. So if the chain breaks, then the governance can intervene, push out one of these forced changes, and everything will kickstart again. This has not been used in Kusama and Polkadot so far. We have never, finality hasn't broken there yet. Hopefully there are no more bugs. All of the stuff that I'm talking about here is from like 2019. And the validators are incentivized to be online. But it has been used successfully on West End because there it's just a test net with no values, so people just come and go, they disable their validators, and they just don't care. So what can we learn from all of this assorted problems? What are the key takeaways from this? The key takeaways is that there are gaps going from like the papers and the specs to the actual implementation. There will be unexpected obstacles, things that are not properly defined in the specs and that will actually be hard to implement. And they are by definition hard to anticipate. So the answer here is to engineer as early as possible. That was our philosophy. We've been running like these test nets with the community pretty much since 2018. Like we have been building stuff and deploying it, as soon as we have it. And this is the algorithm. We deploy things, we see it break, and then we improve it. And this will also, if we do this very early, it means also that these engineering problems will also feed back into the research. And maybe we will actually come up with totally different solutions for problems that we didn't even know we had. Most importantly, we just have to be at peace that this is a chaotic process. We just have to expect chaos, be at peace with it, and basically still have fun while implementing all of this stuff. And that's it. I'm not sure how much time we will have for questions, but let's see.
Yeah, does anybody have any questions? Please submit it through the Ask a Question function. Right now, we only have one question in there, and it's for Bit.Country. So,
yeah, no worries.
Let's give it a little moment. Any questions?
This was maybe like information overload. I'm sorry. I mean, there was still a lot more that I could share, but
No, it's super interesting, like going through it all. Like, I'm not a developer by any means, but for me, it was definitely insightful. Yeah, very thorough talk.
Yeah. I mean, I still have 20 more slides that I couldn't fit in here.
It can do a full hour session on its own.
Yeah.
Okay, we got a question.
Yes.
The hybrid approach, Babe and Grandpa, is mainly for scaling when compared to Tendermint, so voting on chain instead of blocks.
So it has the advantage of, trying to get the best of both worlds. So having the availability of Babe and then getting the consistency of a BFT algorithm on top of it. But in the scope of Polkadot, we really need this because of the way that parachains work. So we want Babe to collect, the relay chain will be collecting these pair blocks, and then we'll have this availability and a validity protocol running on top. And so we want to delay finality so that we give the fisherman time to try and see if anyone is trying to get an illegal parachain block in. So that basically, if that does happen, we get to revert the chain because it wasn't finalized yet. So we really need to catch it before we finalize stuff. There will be, in practice, there will be a bigger gap between the latest block and the finalized block than there is now.
Nice. Any more questions from the audience? I didn't see any coming through since then.
Yeah, no worries.
Okay.
Yeah, I'll be around on Riot, so if people on Elements, so if people have questions, they can find me.
Great. Thank you so much, Andrea. That was great.
Cheers.
Okay, bye. So next up, we have Shannon Christie. Hi, Shannon. How are you doing? Oh.
Sorry, having a battle with turning the microphone off. Yeah, doing pretty good. Thanks, Carol. Thanks for the invitation. Good to be here.
For everybody who doesn't know, Shannon is actually broadcasting from New Zealand at the moment, so it's 4:30 in the morning. So really appreciate the early rise you've done for us today.
Yeah, no, that's all good. It's just really awesome to be able to get involved with kind of like helping out with the community, share a little bit about what we're doing with Bit.Country and stuff like that. So really look forward to this opportunity to be able to talk about it a bit.
Yeah, and with that, let's get started. Take it away.
Okay, all right. Thanks very much for that, Carol. Yeah, so I guess currently living in Auckland, New Zealand. So I've been working with tech from quite an early age, really passionate about software and development and stuff like that. Kind of getting started in programming around kind of like 14 or so, and really just spent a lot of time kind of working on software in all sorts of ways, whether it be kind of like websites, desktop applications, even doing some game development and stuff like that, working with Unreal Engine, for example. So it's been a really interesting journey going through all that. In more recent times, I've been working with the awesome team at MVP Studio. Their headquarters are also in Auckland. And yeah, they have quite a few successful startups. So one of them in particular is actually transacting over 17 million in terms of transactions that are being handled by them globally with customers all around the world and stuff like that. And one of the projects that we're now working on is Bit.Country. So that's a decentralized virtual world, and it's kind of what I'm going to be sharing more about at the moment. So yeah, let me just get my slides shared so you can see them all. Okay, and just a moment. All right, they should be coming up on the screen pretty soon. All right, if you can't see, please just let me know. But otherwise, should be all good. So yeah, with Bit.Country, as kind of already shared, it is a decentralized virtual world on Polkadot. It's something that we've already, towards the later half of 2020, we completed our milestone for the Web3 Foundation Grants Program. Which is really awesome to have that kind of support from Web3 Foundation. We also ended up entering into BlockHack Global 2020, where we won one of the 2 bounties that was available, the Business Vision bounty, and also we're being supported in terms of R&D by Hey Innovation. So kind of talking a little bit about, why do we need a virtual world? It's something that we really feel is beneficial and useful for people like influencers. You have a place where you can create your own virtual world, where you can kind of have a place for your fans, something that's kind of special, something that's unique. And in there, you'll be able to do things with NFTs. It's kind of like one of the focuses of Bit.Country. So talking a little bit about kind of the problems that we see and how potentially we want to try and solve those. First of all, we feel that there's kind of, at this stage, there isn't really a decentralized network that enables influencers to create a virtual world that is really designed for their fans, that has things like governance and assets and economy all kind of built into it as kind of a native thing. So you can already see that this is kind of part of the reason why we were interested in working with Substrate, and that it enables us to do this. The second problem is that at this stage, we feel a lot like a lot of NFTs and things like that. They tend to not really have enough use. They kind of just sit in your wallet. So we feel that they should be on display, like a collection that you have. If you're an art collector or something like that, you want to have people be able to see all the pieces that you've collected and be able to do something with it rather than just sitting in the corner gathering dust. And really the third one is giving more opportunities for your fans to be able to interact with you. Your fans want to be able to get involved with what you're doing more. They want to be able to potentially purchase land inside your Bit.Country. They want to potentially purchase art or many other things inside your space, and also potentially get involved in live events that you could be hosting inside your Bit.Country, and all the while, of course, making sure that that's not being inhibited or kind of discouraged with high gas fees and things like that. Again, another reason why we ended up choosing Substrate for our technology to kind of build a lot of this functionality. So talking a bit more about kind of Bit.Country, our solution, kind of what it's about. So kind of one of the key elements of the whole thing is actual Bit.Country inside Bit.Country. So that is your virtual world. That is the space that you can make yourself. And it's also the space that all of your fans, your residents will be getting involved in. So it's a place where you can all kind of collaborate together. With Bit.Country, we have this idea that, people can kind of contribute to kind of like the story of your Bit.Country. So you're creating this legacy that can continue to live on far into the future with the power of blockchain and things like that. And everyone can kind of have this place, like I said, like with the land, they can purchase it, they can rent it, they can be a resident in your place. And you can display NFTs for people to have a look at them, have a place that you've designed specifically to show off an art piece, to show off some NFT that you've got somewhere. And to kind of encourage some of that activity more, the value of NFTs. Of course, we also support a NFT marketplace, so you'll be able to trade in there. And as was mentioned kind of earlier, governance in terms of like a palette will be enabled for a Bit.Country on a Bit.Country level, so that residents that become members of kind of like the council, they will be able to vote and create new proposals and things like that to kind of decide, how should this country work? What kind of things should we be encouraging? How should the process work? Should we be incentivizing this, and so on and so forth? But you can kind of get, I guess, a little bit of a feel for what we're after with kind of the image on the left, where we're talking about Continuum. So I'll talk a bit about, what is Continuum. So you kind of picture it a bit like a world map in a way. And it's something that, again, it's driven by the community. It's driven through chain logic. So in the next slide, I'll talk a little bit about that. But either way, the point of it is that this world map has a limited number of spots that you can kind of get into. And you need to kind of like auction for that. And once you've kind of secured it, you can put your Bit.Country there. And you could kind of think of it as a little bit like a curated list of countries of higher quality and things like that. And it's something that definitely people want to try and get into the Continuum spot if they can help. But yeah, it still needs to be something valuable and important to a lot of people. So you can kind of see that each world will have its own kind of style, its own story. For example, we have one on the left that's kind of like like it's on Mars or something like that. Another one that's a little bit like a sci-fi future or something like that. We really want to enable people to have that kind of different story for the Bit.Country that fits with, you know, their expression and what they hope to kind of show to the world and things like that. So in terms of Continuum, talking about it a little bit more, with the spots, we are using kind of like a algorithm or function of like the total number of bit countries, and using that to determine when a new spot should become available. And as I kind of said, it's shaped by the community. And what that kind of means is that when there's a new spot available, people will be able to start kind of voting in a way to say, you know, I think that this position should be here or that should be over there. So they get to decide, you know, what's the final shape going to look like. It's really up to them to decide how that works. Once it's then been created, this new spot, the countries can auction for it, then they can potentially put their Bit.Country there. So that's kind of giving you a little bit of an idea about that. There are benefits to being on the Continuum in terms of maybe like incentives and rewards from the system, the network, I should say, and some other benefits as well in terms of encouraging people to want to be there, making sure they're kind of got skin in the game, making sure that they're serious about the whole process and stuff like that. But we can talk about some of those details later on. Another important part to mention for our solution is virtual dApps. So inside the virtual world, you're able to have kind of like activities and things like that. So for example, you could have like a plot of land, and people could kind of invest money into this plot of land to potentially see what they can grow, what they can yield from it, basically. And all of this activity will be done and driven by smart contracts. So part of the platform is we want to make sure that people have the kind of the ability and the place and the tools that they need to be able to create their own kind of experiences and things like that. So if you're a developer or something, that you have the opportunity to kind of make these dApps, you have this opportunity to make a smart contract, to make this UI, and make it so that when people are interacting in the virtual world, they could have something happen. So you could invest some money into this plot of land. As time goes by, maybe it produces or yields some vegetables or something like that, and those would be NFTs that you could collect. So it's kind of all driven by that chain logic that could be determined by people. So we kind of see that there's a lot of interesting possibilities there. So for example, the team experimented with a few different ones, and we had things like a kind of like a lotto type system, where maybe the person has to choose a lucky number. If they happen to get it right, they can win all the funds in the pot. If they get it wrong, the fee for playing would just go into that pool for potentially someone else to win. And there could be all sorts of interesting things there. It could be a kiosk for selling merchandise, for selling your NFT music, or for selling your shirts or something that you could wear inside the virtual world, and all sorts of interesting things like that. And kind of to allow that as well is that people could just be focusing on developing those dApps, and it could be in the store. They don't necessarily have to be a Bit.Country owner. It can be kind of different groups of people working on these things. For people to kind of have that experience if you're not necessarily a developer yourself, for example. So kind of, as I said, we want to make sure that NFTs have a place inside Bit.Country. So we have a marketplace for that, and we want to make sure that gas fees are not going to be a problem with that. So we can kind of customize it. That's a really awesome thing about Substrate. You have that kind of that freedom, that power, to be able to deal with that. And originally, in the very beginning with Bit.Country, we were looking more at Ethereum. We were developing on that, and we kept finding that that was quite a big obstacle for us. That how are we going to handle the fact that the gas fees are getting higher? How are we going to handle a lot of these different interactions that we couldn't necessarily do with Ethereum? We had to start thinking of almost like layer 2 or off-chain to enable some of these things to happen. But with Substrate, we have that ability that we can change it, that we can tweak it, we can control how the gas fees work, when they apply, when they don't apply, and it allows us to have a lot more possibilities that we always kind of wanted to achieve but couldn't do it without this kind of technology. Another thing is that it's helping us with what we always dreamed of, having cross-chain NFT auctions, so that people could be importing NFTs from other systems, other chains, or Ethereum, or anything like that. And again, they can put them inside their Bit.Country. They can trade them on the marketplace and all those kinds of things as well. So that's another thing that really was a driving point for us to get involved with Substrate and Polkadot and all that kind of stuff as well. With the marketplaces at this stage, we have this idea that there's a local marketplace inside of Bit.Country for kind of its own buyers and sellers and everything getting involved there. And there's also kind of like a community level, which is kind of like a global marketplace where people will be able to have kind of a bit more visibility and things like that. But each one kind of serves its own purpose in a way. So really kind of summarizing it again, it's about bringing it to a different dimension in terms of engagement and stuff like that. So we have pretty much creating a protocol that enables a community to shape its future. With the virtual world, it reflects your culture, it reflects your ideas, what you're trying to express and things like that as an influencer. And we have the marketplace where we have kind of more control over the fees, in terms of, you know, when you're selling potentially land, when you're selling art, when you're selling anything kind of on the Bit.Country platform. So here's the team that's behind it all. So we've got quite a few awesome people working on the project, covering many different aspects in terms of like blockchain with Justin Pham, Ray kind of leading the whole project, Daniel helping out a lot with the development, things like that, Logan doing the awesome design work and stuff like that. And we also have our awesome community team helping out in terms of managing the community and things like that. So we have quite a few partners and friends kind of coming through our connection as being a community partner with a Substrate Runtime Developer Academy that's being run by Industry Connect. So if you happen to be joining in with that academy, we offer a optional internship for anyone who's getting involved there. If you're interested to kind of get involved, you have the opportunity to work on Bit.Country. So yeah, either way, we have quite a lot of interesting connections coming through that whole thing. And we've already had some people joining on with the internship and stuff like that, which is pretty cool. So in terms of giving you a little bit of an overview of the currencies I mentioned earlier, it kind of serves two purposes. So at this stage, we're calling it BCG. We're kind of thinking about the naming still at this stage. For now, we're sticking with this. But either way, it is the native token on our blockchain. It does kind of two purposes. It has the utility in terms of paying for any kind of like fees and transactions and stuff like that. It is the currency used for trade, used for purchasing land, for rent, for minting NFTs or anything like that if you need to. And it's also used for staking, which we kind of use in our system, really inspired by Polkadot for quite a few of these things, with staking being a way of ensuring good community behavior and stuff like that, and just keeping the whole ecosystem and community flowing quite well and so on. It's also used for governance, so used for kind of deciding how the treasury should be spent, potentially for grants and programs to encourage growth and things like that, incentives to promote certain activities and so on, like, for example, creating NFTs, getting yourself listed on the marketplace, all this kind of stuff. And like I said, for the Bit.Country behavior. So yeah, there are a lot of people, there are a lot of influencers out there in the world, micro-influencers, and we really think that it's going to be really awesome to have a system or a platform that enables you to have that space to be able to connect with your fans. It could also just be a thing that you do for your own community. So if you've ever been a part of any meetup or something like that, you can really see it's an awesome thing to have that place where people can come together, get involved in that, be part of the culture. And if you have, imagine, for example, Gavin Wood or someone like that having a Bit.Country, I think we'd all be pretty interested to be able to get involved in that, purchase some land and be able to say, yeah, Gavin Wood is my virtual neighbor and things like that. So we have a lot of cool ideas in terms of that. But yeah, it's something that we're really excited to be able to keep going forward with. So here's a bit of an idea of the roadmap for Bit.Country at the moment. I saw that was a question in the Ask a Question. So yeah, you can kind of just get a bit of an idea here that we have already early access in terms of a lot of the primary functionality is already enabled. It is kind of like limited access in terms of not everyone can just jump in at the moment. You need to be kind of invited or get access into it. We are in the kind of the second state at the moment where we're working on creating the features. We already have quite a few things developed, which I'll share a bit more in the next slide. We do have the goal of being, of course, on Kusama. Once we have that, we'll be able to enable that kind of like cross-chain NFTs and things that we really want. And then kind of in the end, aiming to be on Polkadot as a parachain. So talking, where did my connection, come on, swap to the next one, please, that's better. Yeah, in terms of the development progress that we have already made, so we actually already have a proposal to put Bit.Country as a parachain on Recursive. We already have our testnet live. As I mentioned earlier, we've already done the milestone for the open grant with Web3 Foundation. We're part of the Kusama NFT strategy group, which also means that because of that, we are actually involved at the moment in developing the virtual world for the Chiba Art Gallery, kind of using a lot of the tools and technologies that we already use for Bit.Country as getting involved in that and helping out with that, which is really awesome to see. We are supporting the Substrate Runtime Developer Academy, and also Bit.Country is already being piloted with 152 users. So yeah, that's kind of gives you a little bit of a story about Bit.Country. Hopefully it's all made sense to you and you kind of get a bit of a feel for how it all works. If you want to find out any more details, you can check out our Twitter as shown at the bottom there. You can check out the website to find out more about Bit.Country. But yeah, either way, thanks very much for kind of your time, your attention and looking at all this. And yeah, that's all for my slides. Let me just stop. Oh, there we are. Perfect. Cool.
Great. Thank you so much, Shannon. That was really wonderful. I really love the concept of like creating your own little countries and like making neighbors with influencers. I think it's a really cool way to connect with people.
Yes, thanks very much for that, Carol. Yeah, we're really excited to be able to work on something like this.
Awesome. Any questions from the audience? I think we just got one in. Please submit your questions. If I wanted to be a creator at Bit.Country, what kind of tech stack would I need? Okay.
So I guess it depends a little bit on kind of like creator. So that is still a good question. So thanks very much for that, Joran. So with Bit.Country, you don't necessarily have to be a developer or anything like that to be able to get involved. We want to make sure that when it comes to getting involved with Bit.Country, that it's easy for people to kind of get involved with. I guess the only thing is to do the Bit.Country, you need to be comfortable with blockchain. You need to be comfortable with how that works. So just creating a country, all good. We have the goal of having a system like templated worlds and things like that, so you don't have to be a designer or anything like that. But if you happen to be one of those people, then you're welcome to kind of build it yourself from scratch. But you know, not everyone who's an influencer wants to go and spend all their time creating the world as well. In terms of potentially creating like smart contracts and stuff like that, with Bit.Country, we plan to support Inc. For doing the smart contracts, or also kind of like EVM. So you could also be using like Solidity and stuff like that to be able to get involved with that. With the UI stuff, pretty much if you can do web development, you've got HTML, CSS, you've got JavaScript, stuff like that. That would be the main kind of tech stack if you want to be able to do those virtual dApps and such. So hopefully that kind of gives you a bit of an idea on if you want to be a creator. Okay, another one, smart contracts. Will you be supporting? Yes, so I believe I kind of already answered that. So yeah, we'll be supporting kind of like Solidity through EVM, Inc. So we really want to be able to just make it as easy as possible for people to be able to get involved and create that kind of functionality and stuff.
Got another one. Will this be a Ready Player One crypto world and include VR?
Okay, yeah, that's an interesting question. Thanks for that, Douglas. Yeah, so we definitely have a lot of ideas in mind. We have already been considering things like VR, and it's something that we really want to look at further along in the roadmap in terms of enabling you to experience it in different ways. But Yeah, I think it could be a lot like that. We have, the main thing is that each person can create their own virtual world. It's not just a case of we all share one virtual world. Each one can have its own style. You could have like a Tron style on one. If you wanted to have some like Stone Age one, then I guess, sure. Any kind of different thing would be available. But yeah, we want to see about potentially supporting VR someday in the future. Okay,
Cool. Any more questions? It's your last chance. There's usually a little bit of lag on this, so I'll give it like a moment to give people opportunity.
Okay, all good. If there are no more questions, I guess I could also show off a little bit about kind of the proposal that we already have in place for the Bit.Country parachain on Rococo, kind of a little bit about the palettes and stuff that we worked on as well.
Yeah, go ahead.
Okay, all right, sure. Let me just get this up on the screen so it's showing the right place. Show my screen again. Okay. Cool. So it should be sharing very soon. Yep, that's good. Yeah, so you can see that in the test network and stuff like that, that we are already listed in the Polkadot.js app. If you head, so maybe I'll just go here first while we are here. So this is on our testnet at the moment. You can see a little bit about the different palettes and things that the team has been working on. So for example, we have to have things to handle kind of like assets and NFTs and stuff like that. We have our custom palette and module for handling the treasury, for handling auctions, for the block module, for setting up kind of like our smart contracts and stuff. Our council, we're still working on the Bit.Country council level, and NFT module and things like that. So there's quite a lot of different palettes and things that the team has needed to design to enable this whole thing. And again, it's really awesome how Substrate works. It's really enabled us to be able to go further with this whole experience by giving us so much more control than we had when we were looking at other blockchain technologies. We were looking at other ones, and you miss out on some of the opportunities of having that control on the gas fee, having the ability to develop your own logic quickly and easily, to be able to create these potentially fee-free transactions in some cases, if it meets certain criteria and stuff like that. And that was really another big driving force behind this whole thing, and that kind of like the bridges and the cross-chain communication, all that kind of stuff that Substrate and Polkadot and stuff like that have been working on. So yeah, you can kind of check out what's going on with the proposal at this stage. If you head over to the network for Rococo, you head to proposals, and yeah, you can kind of see, here we are with our proposal at the moment. So we're aiming to get up and onto that as soon as possible. So when there are more parachains being accepted into the Rococo network, we're looking forward to when we get the opportunity to get live, have the opportunity for everyone to kind of start using the platform and stuff like that. And we'll be opening out more as time goes by. But yeah, so I think that's pretty much all to share again for now. So let me just stop that again. If there's any last minute questions, we're pretty happy to do that. Otherwise, I guess we'll see.
Yeah, no more questions came in during that, but it was super interesting to see that and going through that. Yeah, thank you for that. Yeah, so I think we will end it here. We're just at the nearly top of the hour, so perfect timing. Thank you so much, Shannon. That was great. Thank you to Andrea, who also spoke earlier. And thank you to all of you who joined us today and listened to our talks. I look forward to seeing you at our next meetup in March. We're planning it for March 25th. And more information will follow soon about that. So thank you so much. Have a great day, everyone.
Thanks, everyone. Thanks, Kara.